Lessons from Fukushima and subsequent fears over nuclear power has forced countries like Germany and Switzerland to phase out their nuclear power. At the same time, the world has been focusing ever more on developing and promoting new sustainable energy, but it is still too expensive to replace the current energy sources. That is why Korea is eyeing nuclear fusion as future energy source. Junyoon reports on where the country stands on the path to securing alternative energy.
Years after the nuclear disaster in eastern Japan, the controversy over nuclear energy, sparked by that event, continues to this day. With the cleanup cost of Fukushima estimated at more than $100 billion, and a 310 square kilometer area surrounding the plant likely unlivable for the next 2 decades, many are seriously questioning the viability of nuclear energy. An alternative that's being seen as a safer alternative energy source has been nuclear fusion. Nuclear fusion uses the same energy producing format as the sun, which is then converted into electricity. This is where scientists and researchers from around the world have come together to develop this new type of energy that could be the next man-made sun. This is the ITER, short for International Thermal-Nuclear Experimental Reactor Center.
So we are trying to realize the same reaction which is occurring in the sun.
So what are the strengths of nuclear fusion energy? Firstly, it makes economic sense. Fossil fuels risk eventually running out, but fusion energy uses lithium or heavy hydrogen from the ocean, which is plentiful and cheap. More importantly, it's safe. Apart from the issue of what to do with the waste from nuclear energy and the possibility of another meltdown, there's also the risk of the same technology being used for weapons. Nuclear fusion energy can't be weaponized and has no waste. Nuclear fusion energy has also close to no risk of an explosion, so this means building these plants near major cities is possible, reducing the cost of electricity cables.
Unlike the burning of fossil fuels, nuclear fusion produces no carbon dioxide. Thus, in a way, nuclear fusion energy is more eco-friendly than fossil energy. Also, its efficiency rates are higher than those of any other energy sources that we have ever known.
Nuclear fusion uses the same concept of the sun, which produces a massive amount of energy from the process of hydrogen fusing into helium. For nuclear fusion to happen, there first needs to be a plasma environment present. Plasma refers to the process in which the atom and atomic nucleus split off from each other when extremely high temperatures are added to gas. The sun and thunder are both forms of plasma. Plasma technology is also used in everyday life, like plasma TV displays and even some lighting. Nuclear fusion technology is made by artificially recreating the process in which solar energy is created by the sun. ITER was first set up in the 1980s with the support of the IAEA, and the US, EU, Japan, and Russia have joined forces with China, Korea, and India as of 2006.
Et 3 décennies de recherche s'ouvrent à nos nations avec l'espoir d'une solution utile à l'humanité tout entière.
Half of the finances of ITER are supported by Europe, and the remaining half are split by the remaining countries in the agency about 9% each. So this means taxes from 7 different countries go into this project. By population, more than half of the world's population is participating in the ITER project.
우리 기술로
And suppose we Koreans use our own technologies and our own manufacturers to supply what is needed for generating nuclear fusion energy. It'll revitalize the production system and create new jobs in Korea.
At the ITER Center in France, we are seeing the building of a tokamak, which is one of the main technologies that go into producing nuclear fusion energy. Each country involved in this project is responsible for constructing different parts of the tokamak. Korea will be building its first superconductor to be completed by the end of this year.
현재 이터 국제기구에 근무하고
As of now, about 32 Koreans are participating and involved in the ITER project. They are responsible for engineering the tokamak, the core of the ITER facility, and other central parts.
이터 장치
ITER hopes to find a way to commercialize nuclear fusion energy. Currently, the tokamak, which has to hold 100 million degrees Celsius plasma in a magnetic bottle, is an extremely complicated process using the most cutting-edge technology. There is an artificial sun in Korea as well. K-STAR, short for Korea Superconducting Tokamak Advanced Research, is the Korean version of this technology. K-STAR is a nuclear fusion research center which was set up in 1995. It took 12 years for its completion with $300 million invested in it by the government.
우리나라 핵융합 연구가
In comparison to the West, Korea had a late start in nuclear fusion research. Yet with its successful completion of K-STAR, Korea has now become one of the leading nations capable of their own one-of-a-kind fusion research.
여건을 갖추게 되었습니다. 그래서
This is the inside of K-STAR. It has already been through many trials of trying to produce 100 million degrees Celsius plasma. The Korean companies that have joined in K-STAR's efforts have managed to benefit from the research done so far, winning contracts of more than $260 million worth of related businesses as of last year.
그 핵융합 발전소를
One of the challenges that we face in making it possible to engineer a fusion power plant is to sustain solar-like, high-temperature plasma for a long period of time. Meanwhile, K-STAR's use of superconducting magnets has made it possible for it to run for an extensive period of time.
장치라는 것을 이용합니다.
Technically speaking, just ITER and the K-STAR on their own cannot produce energy. These two are nuclear fusion test centers, not energy plants.
과학적으로는
The existence of nuclear fusion has been scientifically argued. In the meantime, nuclear fusion still remains unproven as self-sustaining and also unproven as a commercially viable energy source. ITER's goal is to demonstrate its feasibility.
It will take about 6 more years for the ITER to finish building. About 25% of the building is complete at the moment. All the countries involved in this project are planning to set up a nuclear fusion plant in each of the member countries by 2040 and use it as a source of energy.
정부는 핵융합 에너지를
The Korean government, with its goal to commercialize nuclear fusion by 2040, has invested approximately $130 million in core, breakthrough fusion research via K-STAR and its superconducting devices.
규모를 저희가 지원하고 있습니다.
So now I'm really interested if we will actually be able to recreate a man-made sun, and if we can, how soon? The scientists in this area see making an artificial sun as one of the biggest scientific challenges, and there are many hurdles to jump before we get there. One insight into the acronym for the International Thermonuclear Experimental Reactor, or ITER, is that it's the Latin word for path. And this project may just be the path to a viable, safe, and abundant alternative energy source for the future.